Good afternoon and welcome to MAE 106, Discrete Mathematics with Probability. My name is Richard Cohar and this is lecture 14. And in today's lecture, we're going to be doing an example using the principle of inclusion and exclusion. Again, it's very helpful if you give a thumbs up, say hello in the chat. It's always good to see you. I know it's Friday, and what a way to finish the week, right? So, anyone else waiting? Hopefully everyone can see me or hear me okay. Good afternoon. Yes. Test 1, I'm still in progress. Is in progress marking. I'm slower. It just takes me a little bit longer. I'm marking it on paper. So I'll get back to you, everyone. I will send, keep an eye out for an email where I'll send you a PDF of your results. Well, I'll basically go through the test and mark everything. Okay, so keep an eye out for that. We're going to keep continuing with our pi, which was our principle of inclusion-exclusion. Inclusion, principle of inclusion and exclusion. So we had this for two sets, where if we did the number of elements in the union of, say, two sets, A and B, that it's equal to the number in each individual set, A and B. But because there's the overlap, we overcount, and we have to remove that overcounting by removing the number of elements that are in that intersection. With three sets, I have, say, A union B union C. It's, again, the number of elements in each set. Minus the two intersections, the two-way intersections, so where they overlap. So we have to subtract where it intersects with A and B, where it intersects with A and C, and lastly, where it intersects with, so I did A and B, A and C, and the last one is A and C. And because we've removed that, we have to now put back in the three-way intersection, which is where it's A and B and C. Okay. So what our example was is we're going to go back to using that example that we had previously. And we had a survey. There was a survey of 120 students. So in this universe, there's 120 students. And we were told that 46 students have satellite radio. So we'll go. The number in S is 46. So this is satellite radio. The number that had a CD player was 52. The number that had a USB kind of a port is 50. Okay. Then we'll have a satellite and a radio. satellite and a CD player. So that's S and C. We'll say that's 25. The number of students that had satellite and a USB port is 21. Had a CD and a USB port. That's 23. And lastly, the ones that have satellite, a CD player, and a USB port is 16. Okay, so I'll look up at the chat. Hello, everyone. And good. So this is kind of the information that you'll be given. It would be, say, written out in words, but we can translate this into, as you're reading it, you would just kind of write this out. And this is kind of a different approach if you wanted to deal with some more complicated things like, oh, how many people have satellite radio but don't have a USB port. Okay, this is a little bit trickier to use than for the principle of inclusion-exclusion. So what we usually turn to is using a Venn diagram. And to do that, let me start out by drawing out my universal set, which is the box. So there's the U, and we'll do 3 sets. There's 1, there's 2, and there's 3. So these are not mutually exclusive sets, right? They are all overlapping with one another, so we're going to label as no, I'm not going to label these A, B, and C. This is almost out of habit. Sorry. What I will, because we're using S, C, and B. So S, C, and here's B. So what we do then is we slowly work through this data that we're given, and we can fill in our Venn diagram. So we start off with, let's start with this end piece of data right here, which is S, which is satellite, CD, and USB port. And so there's 16 people, or 16 students, that have a radio like that. Okay? And so then what you'll do is you'll just kind of work from the bottom up. Okay, what's the next one that we have? We have C and B. So that area is, and what I'll do is I will use a pencil just to kind of illustrate it. So the C and B, so that's just this whole area in here. But, so we're told there's 23 people here. So, but I already have 16 that's included in this intersection. So, you'll have 23 minus 16, which leaves you with 7. So 7 is what you would fill in for this. So if you were looking for that intersection of C and B, it's 16 plus 7, which gives you 23. Okay, the other thing too is be very careful about when you're adding or subtracting, because it can really, when you make one mistake in one region of the Venn diagram, it will propagate through the rest of the diagram. So be very careful and pay meticulous attention to detail for this. So we're done this. Okay, so the next one that we'll work with is we'll do the S and B. So in S and B, this is this region right in through here. Okay, and we're told that it's 21. So you have 21 minus 16, which is 5. So you will have 5 students in just kind of that region there. So that when you add them up, 5 and 16 gives you 21. So let's just erase this section here. Now you don't have to like shade this in. I'm using this for illustrative purposes. Okay, so in the next one we have S and C. So we're looking at this one right through here. So you have 25, and again we have the 16 that's still in the three-way intersection there. So oops. So you'll have 25 minus the 16, right? So 25 minus 16, that leaves you with 9. So in this right here is 9. Okay, so that's good. And now we're left with the individual sets. So now let's start with B. You'll have 50, which is our total, and we're going to subtract the ones in through here, which is we have 5, 16, and 7. So the 50 minus 5, that's 45, minus the 16, that's 29, minus the 7 gives you 22. Make sure, is everyone okay with what I wrote for 22? Is that correct? Make sure that I was doing the math correctly, right? Is 22 the correct answer? Good. Yes. Yep. Yeah. Okay, good. Okay, so we've done this one. So just kind of notice what I'm doing. I'm kind of leaving a trail of thought so that if you are doing something for a test, you know, I can see, you know, if something went awry, like, oh, you took a wrong number, or there was a wrong error that kind of propagated through the diagram. So, okay. So we have 52. So over here you would have 52 minus 9 minus 7 minus 16. So the 52 minus 9 is 43, minus 7, 36, minus the 16 is 20. Okay. And 20, is that correct? Make sure that I'm... It's always interesting to see if I done an arithmetic error. Hopefully, is everyone else getting 20? Yes, okay, good. And lastly, we have the 46. So you will have 46. Good, good. 46 minus 5 minus the 16 minus the 9. So you have 46 minus 5, which gives you 41, minus the 16, that's 25, minus the 9 should be 16. And just hopefully my 16 is correct. Yeah, so 16 plus 9, 25 plus 16 plus the 5 gives you 46. Good. So if you notice with this, with the approach for this, I started in the middle and I worked my way out. So start in the middle, and work outwards. And paying attention to the arithmetic. Okay. Now that we have this diagram, this can be quite useful and helpful to us now. So you could have a part of a question which is like, how many students don't have any of the three? And that would be the satellite radio, the CD player, or the So what I can tell you is that we have we don't actually have to use, say, now the principle of inclusion-exclusion. What I do have now is all kind of these non-overlapping regions. All these regions have their appropriate numbers. So in fact, what I could do here is satellite radio, the CD player, and the port. And so I can add these all up. So I have 16 plus 9 plus 20 plus 16 plus 5 plus 7 plus 22. Okay. So the 16 plus 9, that gives you the 25, plus the 20 gives you 45, plus the 16 gives you 61, plus 5 gives you 66, plus 7 gives you 73, and then another 22, that gives you 95 students that have a satellite or a CD or a port. Okay, but we also know that in total there's 120, which means that if I want the complement, which is written like this, it's everything else in the universe subtract the inside. So what we get then is 120, right? So you get 120 minus the 95, and that leaves you with 25. So let me just introduce that this is also called the complement rule. So that the number outside of a set, say A, is equal to the number in the universe minus what's inside of that set. So this is kind of important. I'll put a red box around it. Now, here's something. Has anyone noticed what is missing then from the Venn diagram? Does anyone see the people outside? Exactly. The ones who don't have any of these features. So we'll also put in here outside of it, everything outside of it, exactly. So 25. So there's the 25, and if you wanted to put some little bit of writing for that, that would have been the 120, and then we're subtracting that 95, which is on the inside, which leaves us with the 25. Okay. So we have this. We did how many students don't have any of the three, which is the complement of the union. Let's see. We'll do how many students have satellite radio but not, let's say, a CD player. It's not a very common feature anymore. It's starting to disappear out of new cars. So how many students have a satellite radio but not a CD player? So with this, we can actually look and answer this. There's our set here, which is the set of people who have satellite radio. And what we have then is people who don't have a CD player. Okay, so let me use my pencil of math, and we'll shade this in. So this is what we're looking for. Here are all the people who use or have a satellite radio. All in there. Okay, and then I'll take out the eraser, but not a CD player. So the set that has a CD player is everything inside of this ring right here. So we can erase anything that the set C is touching. So that leaves us with just the 16 and the 5. So it's just this area and right through here as well. So you would say it's 16 plus 5, which should be 21. Okay. How about how many students only have a USB port? Okay, so same idea again. We go back, we look at this. And the region, okay, so it'd be everything. So we start out with a USB port. So everything in that, we'll just, everything there. But it says only have a USB port, so it can't have satellite radio, so it's everything. We'll remove everything. We won't say have a satellite radio. Can't have a CD player. And so what we're left with is with 22. 22 students. Okay. Here's another one. How many students don't have a CD player? So if they don't have a CD player, just move this. Okay. So what that means is here is the set of CD player. So there's what it is, but it's don't have it. So it'd be everything outside of it. It's the complement of that set. So it's kind of everything outside of it. Okay, so what you could do is you could add up all the numbers. So you could do, you have 16 plus 5 plus 22 plus the 25, right? So the 16 plus 5, that is 21, plus the 22 gives you the 43, plus the 25 is the 68. Okay. So that's one way you could count it. Or, so this is what we call this is called direct counting, or direct method. A direct method is where we count the things that we want. And count the objects that we want. Okay, simple enough. Or alternatively, we could be thinking about what we had learned in the complement rule, which is, maybe I'll switch to using a blue. So in this case, I know that in total there's 120 students. So again, I can start with my total, which is 120, and I'm going to remove the things that I don't want. And that is, I have that's set C. So it's 20 minus 9 minus the 16 minus the 7. And so what you get instead is you'll do the 120 minus the 20, which will bring you to 100, minus the 9 gives you 91, minus the 16, 75, minus the 7 gives you the 68. Okay, and so in this is an illustration of an indirect method. that means, we count all the objects and remove the ones we don't want. Okay, so you can think of, I don't know, you can usually think of, and I don't think I have anything to, yeah. Okay, so that just kind of illustrates the direct and the indirect method. And that's just a general method in mathematics. It's nothing special pertaining to just, you know, sets. It's in general. Okay. Why is this also important? Let me just kind of be a little philosophical at the moment. Why do it in two different ways? Can anyone think of why I would want to do it in two different ways? Proof to verify, confirm answer. Yeah. Yep, I like those. It's basically to check. Or to build confidence in your answer. Because in life, we don't always have the answer at the back of the book. And what we would like to know is again, okay, I came up with 68, but is that really the answer? And if you have a second way of doing something, you could do it that way and use it as a way to verify, to check, to build confidence in your answer. The other way is maybe one way is easier than the other. So it may have been easier to have directly counted all the objects that we wanted, but there could be cases where it might not be. It could be more quicker to do it indirectly. You'll still have to maybe do it both ways, but it's one of the reasons why it might be easier to do it one way. And the third way is it's good to it's good to think about it in a different approach. Why is this important? Is because, like I said in the second point, which is sometimes it's easier to do it the other way. So if you know there's two ways of doing something, or there's two kind of approaches, and one, as you're working through it, is kind of too difficult or you're stumbling, maybe try the other method so that you can get to the answer. You know, if it's too hard. switch approaches. Because if you find that if you're doing a question and then you keep following the same steps that you did and you're getting the wrong answer, you would expect then to get the same answer that you did if you're following exactly the same steps. So how are you going to get a different answer? Well, or may get a different answer, you should switch your approach. So again, there's two ways of thinking about this kind of counting. Kind of broadly speaking, there's a direct and an indirect. Okay. Okay. And let's see if I have a different, if you're missing data. Okay, so if we go back to this, which was what we had for our Venn diagram, and we can go back to what we had initially. It's getting a bit of a workout. It's got lots of eraser marks now, but you can still read it. We can do something else. Let's do one more question about this. Let's do how many students have satellite radio or not a CD player. Okay, so when we look at this, what we should do is translate this into mathematical notation. So what this is asking for is, it says how many students have a satellite radio. So that is satellite radio. So that would be, we're using S. We have the OR, which means that we're using union. And then we have not a CD player. So that would be C complement. So we'll go back up to here. So this is kind of the important step. While we could easily look at something like this over here, we have 21. We could also translate each of these to set notation as well. But when you start to have like some ors, buts, nots, sometimes this can be helpful for us. So now what we can do is we can shade in the Venn diagram. So it's with union, we can just keep applying our pencil lead. So it's everything in S. So so we just keep coloring in, or everything outside of C, everything outside of the complement. Or sorry, everything outside of C is, so this is the complement of C. with the union, I don't have to worry about if I've already filled in something there. That's okay because that's part of that S. And with the union, I just keep coloring in. Okay. So again, we could do it like this. We do the direct method, so we can just count up all the things that are shaded. So we have 16 plus 9 plus 6. Oh, I have another 16 plus 5 plus 2, 22 plus the 25. Okay, so I have 16 and 16. That gives me the 32 plus the 9, which gives me 41. Plus 5 then gives me 46, plus 22 gives me 68, plus the 25, that gives me 93. Okay. So that's kind of the direct. The other way that we could do it is 120. We knew what that total was. And I don't want, I'm going to remove all the things that I didn't want, right? And in this case, I see that it should have been a little bit easier or a little bit quicker to do this. I could just subtract the 20 and the 7. So I have 27. So it's 120 minus the 27 gives me the 93. And so that's the indirect. So let's say symbolically, what did I do? So what I had done here is I had done all of the universe. And then what I had done is I subtracted everything that was in C. All right, so that's kind of my complement rule. And I also subtract everything that was in C, but I also had to add back in the intersection there, which was S intersect B intersect, right? Because that was the 16, plus I also had to add back in the intersection of S and C. So if I didn't have this, I would just go back and I can look at my data. I had my total universe, which was 120. I subtracted the C, which was 52. I'm going to add back in the intersection 16 and add in also S and C, which is 25. Okay, so hopefully, if I have done this correctly, it's the 120 minus the 52, which gives me 68, plus the 16, which is 84, plus 25 gives me, 109. Did I add this? Did I do this incorrectly? So 120 minus plus the 16 plus the 25, 109. what did I do incorrectly? So I've done the CD player, so I'm subtracting it from here. And then I'm going to add in back in the 16, which is the intersection. Plus, I have, oh, and that is y. Of course. Yes, 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 exactly. Exactly. It would overlap. Exactly. So what I need to do is also, so it's the 50, yeah, I would have the 120 minus the 52 minus the 25. Exactly. Okay. And so I'll scratch that out. So if I do that now, which is using that 9, it's the 120 minus the 52 plus the 16 plus the 9 gives me the 93, and that is what it's going to work out. Perfect. Okay. So in the last 3 minutes, use a Venn diagram. I believe so. Yes. Somebody has said that. Let's try that. Okay. So somebody has written S they did S, okay, union, somebody has written, okay, I'm kind of, I think that it should be C prime. Okay, so let's do that. The union minus, let's try what Raptor says. C plus, okay. Where did my tape? Okay, anyways. N. Okay, yeah, can you just rewrite what you wanted? Just rewrite what you had written. Just put that in the comments while I try to finish up the summary, and then we'll check. So, use a Venn diagram when using answering questions about 3 sets. Can be easier. We also covered direct and indirect counting. One small mistake can propagate. Throughout the problem. Okay, so he's written. Okay, let's test this out. So he's written S. So I'll show this. Okay. Union. He's writing, but you're writing the universe. I think he means C primed. Plus. And C. Oops. Yes. Okay, I think that's okay. Let's see if he's got that. So I have, it's 120 minus, in the CD people, there's 52, plus the intersection of the the satellite people and the CD is 25. So let's check that out. Okay, so 120 minus 52 plus 25 gives you the 93. Perfect, so that's what we wanted. Thank you. There we go. Okay, thank you everyone for tuning in on this Friday afternoon. Again, keep an eye out for your email, and thank you for being patient while we were going through some counting. And everyone have a great weekend. I'll catch you next time on on Tuesday, and we'll have those tests emailed out. Okay, have a great weekend.